Good afternoon to everyone. A very warm welcome to each one of you joining us and across India and beyond. I, Sanchita Biswas, Deputy Manager, Sphere India, am delighted to welcome you all to today's thematic webinar on harnessing GIS for multi-hazard disaster monitoring, advanced early warning systems through spatial intelligence organized under Sphere India Academy. India's vulnerability to multiple hazards, floods, cyclones, earthquakes, landslides, forest fires, lightning, and heat waves highlights the urgent need for robust, science driven early warning system. In this regard, geographic information system integrated with satellite data, artificial intelligence, and remote sensing have become indispensable in disaster monitoring, risk assessment, and response planning. The Indian geospatial landscape, further bolstered by the National Geospatial Policy 2022, has paved the way of innovation, collaboration, and local level application of GIS tools into disaster preparedness. This session aims to showcase the innovations, experiences, and community based applications of GIS. It brings together government agencies, academia, humanitarian organizations, and technical experts to collectively explore how spatial intelligence can strengthen early warning system and resilience. We are honored to have with us an esteemed panel of speakers who will be sharing their expertise across domains of multi-hazard risk assessment, risk early warning systems, geospatial solutions, and humanitarian actions. It is now my pleasure to invite our moderator for today, Dr. Arka Prabha Sarkar, Assistant Professor of NIDM, to guide us through the discussions and introduce our speakers. Before that, I would like to speak a brief about him. Sir holds a doctoral degree in geology from University of Delhi. His research interests are mass movement, soil science, hill slope processes, critical zone studies, sediment connectivity, and geochronology. While working as a project scientist previously, he has played a pivotal role in establishing the Pranmati Basin Himalayan Critical Zone Observatory in Uttarakhand, the first of its kind in the Himalayan region. He is the recipient of Maharishi Kannad postdoctoral fellowship. With this, I hand over to Dr. Akrapama Sarkar, sir, to lead us through today's discussion and introduce our esteemed speakers. Over to you.
Thank you, Sanchita, for that wonderful context setting. So we will be having five speakers in today's webinar. The first session that we have today is GIS for multi-hazard risk assessment, and we are privileged to have Dr. Kiranmay Sharma speaking for us on this topic. Professor Kiranmay Sharma is a professor at the University School of Environment Management, Guru Gobind Singh IP University, New Delhi. With over 23 years of research and 16 years of teaching experience, he specializes in geospatial for environment and disaster management. He has authored several books, published widely in reputed journals, and guided numerous doctoral and postgraduate researchers. A recipient of the Netherlands Government Fellowship and the Jawaharlal Nehru Memorial Fund Award, Professor Sharma is recognized for his contributions to climate change studies, biodiversity conservation, and disaster risk reduction. I hand over the stage to Professor Sharma and Dr. Sharma right now. Over to you, sir.
Thank you, Dr. Sarkar. Thank you for the very elaborative introduction about me. Am I audible to everyone?
Yes, sir, you are audible.
Okay, thank you. Okay, respected dignitaries, audience, and ladies and gentlemen. So I'm given around 15 minutes time to complete my talk. So what I did, I was told, in fact, so I should speak a little bit about the basic of remote sensing, then application in the field of disaster management, mainly risk assessment. So I'm sharing my screen. So if I find any enter screen, okay, enter screen share. Mm, yes, your sharing screen. Is my presentation visible?
Yes,
Please
sir,
let
it
me
is
know
visible.
because
It is
I
visible.
can't see anything except my presentation. It's okay?
Yes, sir, it is visible. It is
Okay.
visible.
Thank you very much. Okay. So I'll be with you around 15 minutes time. So by 3:30, 3:20, I will try to wind up. So this is the topic I'm going to discuss today. That is remote sensing and its application in multi-hazard risk assessment. So I made my presentation. The topic itself is telling like first part I'll be talking about the detail about remote sensing, then little bit about disaster management. What are the different stages of disaster management? But I know many of the coming resource persons they will be
ऐसे क्यों ले लिया?
discussing
इधर से
detail
हमारा
about
पेड़ क्यों ले काट दिया?
stages of different stages of disaster management. So how we can correlate the aspect of remote sensing as well as the characteristics of disaster management. So I'll try to link it. So remote sensing aspect as well as the disaster management aspect. First part, let's talk about the subject remote sensing. So I'll start from the very basic. So what could be our understanding being a common man of the subject remote sensing is simply using instrument to record an object or phenomena of the art without coming into physical contact. That machine is placed somewhere in the elevated platform, and from there we get information of the art surface about different phenomena, different aspect of the surface of the art. That's what our first understanding about the subject remote sensing is. So many uh, aspects are there, of course, but here I'll be discussing how electromagnetic spectrum is contributing in this particular field. So all of us are aware about management of light wavelength. That's what we understand about electromagnetic spectrum, and it has wide applicability, particularly in the field of remote sensing. So these are the days of digital imagery, digital photograph. Every one of us getting a digital camera with us installed in our mobile phone. So to get a photograph, we need energy. So we're talking about the passive type of remote sensing, where source of energy is the sun. Sun is the source of energy, and sun rays it travel and it hit the surface of the earth. We have many resources on the surface, and these resources, some of the resources are good in terms of absorption, some of the resources are good in terms of reflectance of the incident energy, some of the resources, some of the objects are good in terms of transmitted. So depending on their capability of reflectance, different objects they will start reflecting back the incident energy in different proportion, and this energy which are reflected back by different objects are captured in the sensor mounted in the satellite, and satellite send this signal, this energy to the processing unit, and processing unit they prepare an imagery which is of digital in nature, means this imagery are composed of pixels, and these pixels make the complete study area. In that particular image we can see all the objects which are sensed by the sensor, and depending on the reflectance value, these values are captured by the individual pixels, and this value of pixels also equal digital number tell us about the object it changed. So this I have some graphic. Probably what we talk about will be clear once we see the graphic. These are different stages involved in remote sensing. A source of electromagnetic energy, that sun is the source of electromagnetic energy, transmission of energy from the source to the surface of the atmosphere. Of course, in between sun and surface of the earth there are many phenomena occur. Some of the energies are absorbed in between, and most of the lion portion of the energy reaches the surface of the earth. So once it reaches, it interact with the earth surface, and this is transmitted from surface to the remote sensor and sensor data output Once we get that output, the data is prepared and data can be transferred, can be processed, and developmental activities. So what we talk about, these things are shown in graphical form. Sun rays hit the surface of the earth, and we know again light always travel in wave-like form or sinusoidal form. Anyway, so once the light hit the surface of the earth, this energy, this incident energy are reflected by different objects depending on their reflecting capability, and this is stored in the sensor mounted in the satellite. Once these energy are stored in the sensor, these signals are sent to the processing unit. In the processing unit, based on the energy sent by different objects, are captured by individual pixels, and these pixels make up the complete study area. And once we have this type of imagery, this digital imagery, this imagery can be utilized for different developmental activities. This processing unit in Indian context, we have NRSC. All of us know the NRSA. Previously, it was known as NRSA, National Remote Sensing Agency. They are the apex body of doing all pure and imagery. But these days, we have archive of imagery, and those imageries can be freely downloaded. So besides this satellite, we can have aerial photograph where we require data on an urgent basis for any disaster scenario, post-disaster scenario. Then aerial photograph also can be utilized. In this way, we can have two different type of imageries. One is satellite-based, one is we can procure, and these can be utilized in the field of disaster management wide scale, wide way. So I was talking about electromagnetic spectrum. So imagery is taken from the elevated platform. So whatever objects are there on the surface of the earth, all objects will be depicted in that using visible portion of the electromagnetic spectrum. Eyes only can detect the visible portion of electromagnetic spectrum. All resources can be seen in that particular imagery. But there are many phenomena, many risk phenomena are going on that cannot be seen by our naked eyes. If we have the scope of utilizing the bands beyond electromagnetic spectrum like infrared or microwave, infrared can be near infrared, mid infrared, or far-mid infrared. If yeah, that image can be showing the differences in temperature. All of us probably aware there are underground coal fire going on in many coal mine areas, particularly in Jharkhand, Jeria coal field. There are uncontrollable fire going on underground. If we have an imagery using thermal portion of electromagnetic spectrum, that imagery can tell us about the areas where there are underground fire, which are the areas experiencing hot temperature. Devastating this particular year. If we want to map the flood inundated areas in the monsoonal region, that if we use an imagery using optical portion of electromagnetic spectrum, that visible portion of electromagnetic spectrum that cannot go beyond the obstacle like cloud cover. If we have that image, this portion 0.4 to zero point 0.7 micrometer of electromagnetic spectrum, in that particular image we cannot see anything other than the cloud cover. But if we have the scope of utilizing, we can penetrate through the cloud, and what is there down to the cloud, everything can be mapped, everything can be seen in very good way. So in this way, remote sensing having wide utility of electromagnetic spectrum. Okay, so all of us are aware of Google Image. If we see the Google Image down right hand side in the image, right hand side in the screen, it is written GUI. Sometimes it is written Iconos. Sometimes it is written QuickBird. These are the name of the sensors which are very good in terms of spatial resolution. Pixel size in those imagery are very, very small. If it is written iconos, then size of the pixel will be 1 meter. If it is quick bird, then size of the pixel will be, if it is a pixel will be 0.35 or 0.5 meter pixel size. In an imagery with 1 meter pixel size object, it in that particular image, and in that particular image, and we can see very clearly all the objects. Even our vehicle parked also can be seen in that particular imagery. The one we see in the Google image, particularly for the urban areas, this type of imageries are installed. So this type of imagery, high spatial resolution imagery, are used for the urban study for damage assessment. Because of any disaster scenario, these high resolution imagery are widely applied. So our objective can be little bit different. Our in other stage of, instead of post disaster scenario, we want to identify the buildings which are vulnerable in terms of earthquake, in terms of fire. In that case, we will be identifying the areas which are probably made up of adobe buildings. When we talk about the buildings which are of slum area, these are buildings attract fire very fast. So these are the areas, vulnerable buildings in terms of earthquake or in terms of fire disaster. In that case, we'll be utilizing the imagery where having moderate resolution, moderate size pixel, maybe 20 to 30 meter pixel size imagery can identify areas which are of slum area or unplanned urban areas or adobe buildings occupied areas. But our study could be objective, could be different. We are more towards the climate related study. In that case, probably will be requiring the large area coverages. Suppose Indo-Gangetic Plain, we know that agricultural land, paddy agricultural land, they are emitting the maximum greenhouse gases, and we can identify the paddy agricultural land in their energetic plan, and whatever objective we have in that particular study, we can go forward with those areas. But it is surprising sometimes. There are imagery of 1 kilometer, 4 kilometer pixel size. Immediately things come to our mind, like what could be the utility of this big pixel size imagery? Because smaller than 1 kilometer, smaller than 4 kilometer pixel size imagery, we cannot object we cannot see in that particular image. But these are the images what applicable in the field of disaster management. So if we have large pixel size imagery, definitely those imagery will be having large area coverages. Large area coverages mean if we go at one go, then entire hemisphere of the globe can be sensed, and we'll know in which part there is moisture bearing cloud, in which point the generation of cyclone. If we have the imagery which are taken in very short duration of time, suppose every half an hour we are getting the image cyclone generated in this particular point. After half an hour, at which point this cyclone would reach, we'll know the speed of the cyclone, we'll know the direction of the cyclone, we'll know the velocity of the cyclone, and we'll know after how many hours this cyclone would reach the coast. Life and property of the people living in the coastal areas can be saved. So the recent success story of Dana, Hurhur, Takti, Ramel, Yes, Asani, Fani, these are the cyclones hit the Bay of Bengal, that Fani, that Mosa. So there are very minimum impact of these cyclones of this technology, so that the proper tracking of the cyclones can be achieved. So the acquisition between two times, that is called a rapidity. If the Delhi is sensed today, after how many days Delhi will be sensed again, that duration is called the temporal resolution or rapidity. Then previously I was talking about the size of the pixel, that is representing the resources, representing the art surface. So that is the spatial resolution. What is spatial resolution? Size of the art which are captured by individual pixels and helps us in representing two objects. That's a spatial resolution. Or we can say that minimum area that a sensor can see is the spatial resolution of a particular sensor, a particular satellite. In this way, we can have understanding about spatial resolution and temporal resolution. Another type of resolution is there, that is spectral resolution. The range of electromagnetic minimum range from the electromagnetic spectrum will be utilized, then we may not get very minute details about the object studied. But if we have scope of utilizing the wide range from the electromagnetic spectrum, definitely it will help us in getting maximum information of a particular area. Why I discuss all these things, because this aspect will relate with the disaster scenario. So spatial resolution defines the size of the earth surface that is stored in each pixel. Spectral resolution, the range of the wavelength studied, so defines the wavelength intervals. Temporal resolution defines the repetitivity of the satellite. Okay, so let's talk about the disaster and hazard. We know what is hazard and what is disaster. Hazard, it's a potentially damaging phenomena, but when it occurs in densely populated areas and there is huge destruction of life and population, and local governments cannot cope up with the situation and needs to take external aids for to cope up the situation. And when this type of situation occurs, then stars also have all these characteristics where it from the source. When we talk about earthquake, scale of the objects, these all characteristics of spatial aspect of any disaster. Spectral aspect is how they will help in identifying those. All will come under spectral. Temporal, length of the event, possible repeats, delayed effects. These are all coming under characteristic of any disaster. Data also, we have already talked about having spatial, spectral, and temporal characteristics, and we try to correlate this aspect. And
Sir, sorry to interrupt.
yes,
We are
everything is.
running against time, so I'd request you to kindly wrap up as soon as possible.
Yes, it's another 5 minutes time. You give me 5 minutes time. I'll complete in 5 minutes time. Okay. Okay. So this is how just I try to link between the data and the disaster type. So okay. So this is how we can have all these different aspects. Okay. So what can remote sensing can contribute in disaster prevention, disaster preparedness, disaster relief, recovery and recovery things. And we are talking about the spaceborne and airborne data and how this can help us in getting results in different stages of disaster management. And basically remote sensing and GIS, it has contribution. So I'm discussing two case studies. Per case study I'll be taking 2.5 minutes time. So one was done, it was for the flood hazard risk assessment. There is proposal of setting up LPG project in one of the province in Oman. So what we did there, the organization, they were looking for whether that particular area is free from any flood related activities. That particular plan is set up, and in that case what we did, this is the study area, and we prepared different maps. Few maps are related to the entire study area, few maps are related to the project site. So this is the study area. We can see these are the elevation with the drainage, then drainage basin, which are the drainage basin contributing water to that proposed study site. And we found that B, C, and D, these are the three drainage basins who are contributing water to that particular site. And this is hillside with the drainage. These are all catchment area map, slope with the drainage, then contour with the drainage, then aspect with the drainage, then flow direction, then curvature in which direction water will be flowing, then drainage density. All these maps are prepared, which are for the catchment level. And project level, we could prepare some map. This map is for 1 meter contour interval, and this map is for 0.5 meter contour interval. If we have this type of output, then we can have our a conclusion whether flood water will be stagnant within this particular region or not. This is very, very obvious. If we have the slope map for the area, if there will be rain-like situation, flood-like situation, in which direction water will be going out to reach the bigger water bodies in and around. This is the flow direction, in which direction water will be flowing. So this is the elevation, and we can see in which direction that water will be going out. So this is the project set. And from our study, this a project was sanctioned, this project was approved. Okay, so another okay, these are the things where another study was done on it. That soil erosion vulnerability mapping to be done for the proposed hydroelectricity power plant in Tawang district of Arunachal Pradesh. What we did, we studied different ecological factors and different, not ecological, different factors, geological factors who are contributing soil vulnerability, already fragile Himalayan the district. So giving weightages, influences in different aspects of related to soil erosion, weightage influences were given, and based on that, we could find out some classes of soil vulnerability like high, moderately high, moderately low, and low for the entire district. And these are the areas where there were proposal of setting up micro hydroelectricity power plant. What we did, we drew 10-kilometer radius from the proposed site, and we could find the impact zone if there will be a micro hydroelectricity power plant, how much area is under different categories of soil. In that case, we could find out the vulnerability class for the different sites, and accordingly we could complete this study. And this study was sponsored by Ministry of Environment, Forest and Climate Change, and the previous study was done after the request received from the Oman, Royal Oman thing. So in this way we can have some study which are of our own study. We did all these studies, and these studies are already published in very good reputed journals. Thank you very much for giving the opportunity. Thanks. I think I took 15 minutes, 2 minutes more than.
No,
It's okay.
it's fine. It's absolutely fine, sir. You can stop the sharing.
Yeah, thank you very much. Yeah, it was pleasure, and hope
Thank you,
I
sir.
could.
I'll get back to you during the open discussion session.
Sure.
For the next session, we have Mr. Ashok Thakur. Mr. Ashok Thakur is Senior Consultant, GLOF and LOF at the National Disaster Management Authority, Government of India, where he leads initiatives on glacial lake outburst floods, landslide lake outburst floods, and GIS-based early warning systems. With expertise in remote sensing, GIS, geography, climate change, and disaster risk reduction, he has been instrumental in integrating satellite data, IoT sensors, and predictive modeling into India's disaster management framework. At NDMA, he has contributed to pioneering projects such as real-time monitoring system for South Lonak Lake and Shakorchu in Sikkim, national scale flood and landslide early warning initiatives, and capacity building programs for states and UTs. He has also represented NDMA at national and international forums on disaster resilience, climate adaptations, and geospatial innovations, strengthening India's commitment to technology driven and community centric disaster risk reduction. Over to you, Mr.
Thank you so much, Dr. Sarkar. First of all, I want to inquire, I am audible or visible?
Yes, sir.
Yes, sir,
You're
both.
audible and visible.
Audible and visible.
Thank you so much, Sphere India, for giving this wonderful opportunity to speak on this subject. And this is my very core to heart, this subject, remote sensing and GIS also, and its application. So we are in the field of disaster management. So I am sharing my presentation. Is my presentation audible, visible? Sorry.
Yes, yes, sir, it is visible.
Yes, it's in slide mode, so I'm not able to see you all. Just a minute. Yes, share. Yes. So here is my topic for harnessing GIS for multi-hazard disaster monitoring and early warning system. So in session 2, it is for innovation in GIS-based early warning system. So I want to give you some overview of early warning system. What are the principles and components? So previous speaker has enlightened us for entire things about how remote sensing is working. So, visible what? Second. Showing my screen only.
No, sir, it is visible, but it is not moving ahead.
Now it's visible. Slide
Yes,
is visible or not? So
the slide is
here is
visible.
okay. So here is overview of early warning system. As per the UNDR framework, there is three basic principles: timely and accurately and people-centered approach. There is four components as per UNDP and UNDRR. There is response and capability, risk knowledge, monitoring and warning, dissemination and communication. How these four components works: risk knowledge, systematic data on hazards, vulnerability and capacities; monitoring and early warning system, real-time data collection and forecasting; dissemination and communication, clear accessibility alerts. It's happening again and again. So the dissemination and communication, clear accessible alerts to at risk communities, and response capability, preparedness for action including evacuation. So how GIS does these points? This for mitigation we have zoning, risk mapping and forecasting. For preparedness, scenario models, inventories, response, live dashboards, crowdsource reports, and recovery, damage assessment, rebuild tracking. So GIS integrate all the spatial data for these modeling and visualization, because data is most important for any analysis. So in GIS integration and early warning system to enhance real-time monitoring by remote sensing, for example, ISRO satellites and foreign satellites are working for spatial analysis. Predictive modeling is very important. Simulate hazard using AIML on geospatial data. Data integration combines weather topography and socioeconomic layers for multi-hazard alerts. So what are the benefits? Improve accuracy. For example, if you heard about the super cyclone of 1990, so there was thousands of casualties that time. So now our early warning system at IMD is very precise, and it gives very good information, and now the casualty rate is almost zero. So in the right panel of the slide, you can see the whole scenario, how GIS environment is working. We get images from satellites, and how the all components we can use the applications of the remote sensing, like urban planning, disaster change analysis, climate change services, transport and precision agriculture. So GIS based landslide modeling and real-time monitoring. GSI is the premier agency to identify the susceptibility of the landslide area. As you can see in the right side of the map, these red area is representing the highly susceptible area for the landslide. So this area is also prone to the earthquake also. So there are almost 183 districts which are almost highly prone to landslide, and therefore we need modeling, use topographical data, various database like rainfall thresholds, slope stability analysis, real-time monitoring like IoT sensors, and GIS dashboard for debris flow detection. Innovations, there are so many early warning systems are working on this, which are in the pipeline also. And NDM is focused on landslide, lake outburst, and glacial lake outburst flood also. So I am handling the glove here. So I want to give you the whole picture of glacial lake, how the glacial lakes are there in the entire Indian Himalayan region. So here is in the right side, you can see the atlas of the NRSC that is published in 2023. So most of the glacial lakes are above 4,000 meters. So these are various types of lakes like moraine dam lakes, ice dam lakes, glacial lakes, and other glacial lakes. So there are almost 28,043 glacial lakes in three basins: Brahmaputra, Ganga, and Indus Basin. So the importance of remote sensing and GIS is to get the glove hazard, and we have to identify the exposure areas. So how we can see in the subsequent slides. So this is the slide of the Gevangath. This is the glacial lake situated in Himachal Pradesh, that is in Lahaul Spiti district. So you can see how the lakes are enlarging. In 1989, the lake area was 36.49 hectare. So now in 2022, the lake area increased to 101.30 hectare. In the right side, you have seen the time lapse of the glacial lakes, how the lakes is evolving and enlarging. So recently, we cannot say the that is glove. There is various hypothesis, and in Dharali, Uttarakhand. So here is I have some two three slides which can give you the more about this, what happened on the 5th August at Dharali. You can see that visual how the whole Dharali has been washed out. I once split again this, so you can see this is Maxar satellite imageries. So only GIS is the way how we can identify what are the main reason for this these devastated hazard happen in this area. So I have identified two glacial lakes there. One you can see in the left side in down, and one is at the top of the ridge. So there is moraine glaciers, and moraine has been made there, and the elevation profile, you can see the how the elevation is there. There is almost a steep slope, more than 68% gradient is there. So here is the damage assessment of Dharali area. So you can see how GIS can help us to monitor and to get the damage assessment of this area. Almost 17.49 hectare of land was buried under the debris, and 69 buildings and 2 bridges were completely washed out. This is basically a preliminary report. Now we are going to conduct the PDNA for this area. So how the mitigation measures are required for this, and early warning system, how early warning system is working. We have two EWS early warning system. These are not early warning system. Basically, these are automated weather and water station, and these are installed in two glacial lakes. One is at South Lonak, second is in Shakucho glacial lakes. So we get the various parameters of data, climatic data like temperature, humidity, air pressure, wind speed, etc., from this weather stations, and precipitation data, and how the lake level is there. We have installed two pressure probes in the under the glacial lakes, and we can watch the water level of the lake and lake level of the lake. So we can get the temperature of data, temperature data, how the lake is, how the temperature is rising or fluctuating. You can see the from September 2023 to August 2025, how the temperature is rising and fluctuating. So this is the daily footage from the South Lonak Lake. We get photograph from every day at 9:30 from these early these stations, and we can identify how the lake is behaving. So these are some multidisciplinary equipment surveys for monitoring electricity resistivity, tomography, ERT, bathymetry survey, hydrological studies, geological study, topographic study, and susceptibility assessment. These are only possible through the GIS and remote sensing. So how bathymetry survey is very important. You can see the depth of the lake. We can measure by the bathymetry of the lake. This is the ERT of the Shakocho Lake. So I'm coming to lightning resilience and hazard specific risk communication. So GIS role is to map lightning hotspots using ground sensors and satellite data. So IMD networks covering almost 90% of India. So lightning resiliency in India campaign GIS enabled apps for real-time alerts. So Damini is disseminating these warnings to your mobile phones, and risk communication hazard specific layers, for example vulnerability maps of rural areas ensure target measuring SMS mobiles. So integration of multi-hazard data for timely alerts. Since NDMA came to its existence, so it was in the mandate of NDMA to execute the multi-hazard database for the entire country. So we have conducted one study for multi-hazard assessment. Therefore, various hazards has been taken. For example, cyclone, landslide, um, major hazards, floods, drought, glove, heat wave, etc. So this is the whole. This is the multi-hazard map of the India. You can see here. You can see the earthquake zone 4 and 5, cyclone area, landslide area, flood and drought area. So these are some examples of successful early warning implementation in India. NDM portal, which is giving the forest fire hotspot, now cast warning, coastal current, storm surge, flood watch, earthquake, and everything you can see in the NDM portal. So various agencies like IMD, CWC, these agencies can give you the early warnings. So I have listed some agencies, 10 agencies which have made their early warning system. IMD, Central Water Commission, Geological Survey of India, Forest Survey of India, IITM has made for lightning and air quality EWS, INCOIS, which gives you the tsunami and earthquake early warning system, DGRE, which is pertaining to avalanche warning system, NISAC, ISRO flood early warning system, and for the Northeast region, National Geospatial Program landslide and coastal hazard projects. And what is our priority enhancing early warning system? So we have to establish a dense network of automatic weather stations, flow meters, Doppler radars in remote Himalayan areas. So if you can see the present example of Dharali, so there is one EWS installed at the Harshil. What that gives you the chorus, that has given the chorus warning. So we have to develop some more automated weather station or Doppler radar to get more precise and accurate warnings from the entire Himalayan region. Yeah, so we have to integrate satellite imageries with ground data for advanced forecasting, IMD to lead modeling for cloud blast, globes and landslides, GSI and DGRE to contribute geospatial seismic data and avalanche forecast, Vardy Institute for Himalayan specific hazard mapping, NDMA, STMA, DDMS to coordinate multi-hazard EWS, collaborate with STC, NGI for high altitude simulation models and training. So what are the benefits? Reduce response time, predict event like Chamoli that happens in 2021 and South Lonak happen in 2023 October. Aim for high resolution forecast tailored to mountainous terrain. So conclusion is only that to adopt GIS tools for localized preparedness and collaborate for scalable solutions. Thank you. Thank you all from my side.
Thank you for that wonderful talk. I'll get back to you during the open discussion session. For the next session, we have Dr. Priyanka Shukla. Dr. Priyanka Shukla has recently completed her PhD on geospatial and machine learning approaches for forest fire mapping and analysis in Northeast India with special focus on Mizoram under the supervision of Dr. Derek Sprays Shukla from IIT Mandi. Her research expertise includes forest fire mapping analysis, land use and land mapping, and air quality monitoring, along with the development of an automated web application for burn scar mapping across India. She is currently working with the Atlantic International Research Center, Portugal, where she continues to apply geospatial technologies and machine learning for environmental monitoring, disaster risk reduction, and climate resilience. Over to you, Dr. Priyanka.
I guess her internet is not working. Um, Dr. Priyanka, are you here? Ma'am, we are not able to hear you.
Am I audible?
Yes, ma'am,
Yes,
you
you're
are
audible.
audible
Yes.
now.
Are you able to see my screen?
Yes,
Yes.
perfect.
Sorry for the interruption. Uh, Good afternoon. I'm Priyanka Shukla. I have recently completed my PhD from Indian Institute of Technology, Mandi, where I presented my doctoral research on geospatial and machine learning approaches for forest fire mapping and analysis in Northeast India, with a special focus on Mizoram. At present, I'm working as an Earth observation developer at Atlantic International Research Center, focusing on space systems and their applications. AIR Center is an international organization based on science, able to bring together partners from the countries of Atlantic Basin. At the Atlantic International Center, I'm working on space systems and applications domain. Now, I would like to bring the focus to my research journey. We have all heard of major forest fire events that have made headlines globally, from the devastating fires in Los Angeles to the widespread destruction in Amazon, and more recently, the challenges faced in Portugal, Mizoram, and Maui. These fires scorched hundreds of hectares of forest. Unfortunately, these were not the first and they will not be the last. What's concerning is that these fires are growing in frequency, intensity, and unpredictability, driven by complex interaction of climate, topography, vegetation, and human activity, and yet our ability to anticipate, map, and manage them is still limited. My research addresses this challenge at the intersection of geospatial science and machine learning. It seeks to answer a vital question: can we accurately map and predict forest fire risk in the northeastern Himalayas, one of the most remote, biodiverse, and fragile landscapes in India? In the next 15 minutes, I will walk you through the challenges, data, models, and insights, and showing you how the patterns and predictive models can empower more informed fire risk management in the region. This slide outlines the flow of my presentation, starting from the broader context of forest fires in Northeast India. The study gradually narrows down to susceptibility mapping, burn severity mapping, burn scar delineation using both traditional and AI-based geospatial approaches. So, why wildfires matter for us? Forests are not just trees, they are water sources, oxygen providers, homes to animals, protectors of our soil. When forests burn, people lose houses, farmland. Smoke affects health far beyond the fireside. Valuable biodiversity vanishes. Economically, the true loss is immeasurable. In today's world where developed countries discuss carbon taxes, India's forests are hidden treasure. If we keep them safe, they can become global asset, but once burned, their carbon storing ability is lost forever. The challenge is limited resources. In places like Mizoram, the terrain is hilly, roads are sparse, and reaching a fire site is very difficult. We don't have unlimited helicopters, fire brigades, or trained personnel. Most facilities are concentrated in cities like Aizawl, leaving remote areas vulnerable. So, the big question is, how do we use limited resources in smartest way possible? The solution is mapping plus AI. Satellite act as eyes in the sky, watching over vast forest landscapes daily. Machine learning act as the brain, learning patterns of dryness, vegetation, and past fire incidents. Together they produce fire susceptibility maps. These helps us to prioritize resources, train local communities, and plan evacuation and awareness. The objectives of this presentation are three. First is to analyze long-term spatiotemporal trends of forest fires in Northeast India, then develop a high-resolution machine learning-based susceptibility map for Mizoram, and assessing the burn severity using indices like DNBR and quantifying the impact on vegetation and number of buildings falling in each severity class. Forest fires can be defined as any uncontrolled or non-prescribed combustion or burning of plants in a natural setting such as forest, grassland, brushland, or tundra, which consumes the natural fuels and spreads based on environmental conditions, for example, wind and topography. Its causes can be natural like lightning, high temperature, low humidity, strong winds, and man-made causes like cigarettes, flames, electric sparks, near flammable material, and human activities like land clearing, agriculture, grazing, hunting, industrial work, or negligence. Types of fires can be ground, surface, and crown. Surface fires, they burn only the surface litters like dried leaves, twigs, and grasses, and these are commonly found in northeastern Himalayan region. So we have chosen this Northeast India study area. It has 25% of India's forest area according to Indian State of Forest Report 2011, and the major forest types found in this region are evergreen, deciduous, bamboo, dipterocarpus, sal, teak, and pine. So for this study, we have used the following data sets. Firm's NASA datasets from 2001 to 2022 for spatial and temporal analysis of wildfire distribution, Modi's dataset for mapping vegetation and identifying fire-affected types, ERA, CHITS, and Terra Climate for hydrometeorological analysis and correlation with fire points. So first of all, the spatio-temporal analysis for the forest fire points in Northeast India says that the Mizoram is the worst affected state, followed by Manipur and Assam. And now we will discuss the forest fire hotspots in Northeast India. This figure presents the optimized hotspot analysis based on fire radiative power in Northeast India across 6 periods. The hotspots are the regions of concern where fires are frequent, while cold spots are the regions where fires are rare or less frequent. Persistent hotspots, example Mizoram and Manipur, were found. Detection of spatial shifts in wildfire zones, example emergence in Nagaland and decline in Meghalaya over the time, and the increase in cold spots over time suggests that some regions have seen a decline in fire activity, possibly due to the land use changes and conservation measures. So this is here we can see emergence of hotspot in between 2005 to 9 in Meghalaya region. Then this is the period. This is the area of consistent cold spot, and this is the region of consistent hotspot. This figure shows the frequency of forest fire counts in Northeast India. Yellow, orange, red, and purple shows the increase in frequency. The worst affected years due to forest fires were 2003, 5, 7, 8, 14, 18, 21, and 22. Now we will discuss the hydrometeorological parameters and fire prone versus non-fire prone areas. The temperature patterns says that maximum air and soil temperature in fire prone areas, which are shown in red color here, ranges between 23 degree to 26 degrees Celsius in March, April, coinciding with the peak wildfire season, and maximum temperatures ranging between 14 to 17.5 degrees Celsius at non-fire prone areas, influenced by westerly winds creating a cooling effect. Steeper temperature slopes in fire-prone areas shows that faster heating due to exposed surface, dry vegetation, and solar insolation. And wildfires increase dry vegetation, soot, and gas emissions, which trap heat and keep the temperature high. We can see the flathead in consistent flathead in the fire-prone areas. And overall, an increasing trend is seen. The precipitation trend says that the comparable total precipitation in fire-prone and non-prone areas ranges between 0 to 80 mm due to Mizoram and Northeast India's high forest cover and rainfall. More rainy days in non-prone areas. Non-fire-prone areas experience longer wet periods, while fire-prone areas have shorter and intense rainfall events. So overall findings were the worst affected years are these. Among the northeastern states, Mizoram was the most affected, followed by Manipur and Assam. Identification of persistent hotspot in Mizoram and Manipur. Spatial shifts in wildfire zones, emergence in Nagaland, decline in Meghalaya. Fire-prone areas also showed steeper temperature slopes. And fire-prone and non-prone areas receive substantial rainfall annually, but non-prone areas experience more rainy days. During the fire season, precipitation over fire-prone areas was slightly higher, potentially influenced by fire-induced convection and increased evapotranspiration. Next, we will discuss the forest fire susceptibility mapping, which is another solution. It refers to the likelihood or the tendency of a specific area to experience forest fires based on various environmental, climatic, and human-induced factors. These are the factors which were used in order to prepare the forest fire susceptibility map: digital elevation model, slope, aspect, curvature, solar radiation, land use, land cover, normalized difference, moisture index, vegetation, enhanced vegetation index, vegetation adjusted reflectance index, and topographic wetness index. And these are the machine learning models which we have used in order to prepare the forest fire susceptibility maps like ADAPUS, decision tree, and so on. So first of all, we prepared the land use, land cover layer from Landsat data. Then we prepared the Sentinel-2, these layers from Sentinel-2 data and these layers from ALOS Pulsar data. We resampled all the layers, normalized them, then did the multicollinearity analysis in order to find out which layers are highly correlated and which are not. The highly correlated layers were removed and the remaining layers were selected for preparing the susceptibility maps, and experimented with 6 different machine learning models in order to identify which one is performing best. And later the accuracy assessment and validation was done. So these were the results which we have got. Here we are showing that ROC curve is a graph which is showing the trade-off between true positive rate and false positive rate. And AUC is the numerical value of the area under curve, which summarizes the overall performance of the binary classifier. And here we have found that the random forest is performing the best among all of them. Then these were the susceptible locations which we have found using our susceptibility maps. And later we have found out that the locations which were falling in high susceptibility have caught fires based on, we can clearly see in these planet imagery shown here. And we can also see that ADA boost is highlighting this region into the moderate severity zone, while ADA boost and random forest are falling them in moderate severity zone, while other classifiers are falling them in high severity zone. So there is a certain amount of uncertainty in the results as well, as we can see. Then overall findings says that random forest performed best. Key features influencing the fire susceptibility includes normalized difference moisture index, enhanced vegetation index, digital elevation model, slope, aspect, and solar radiation. And high fire probability observed in south-facing slope, flat curvature, low-high elevation ranges, and low NDMI zones. Open forest and mid-range EBI were more prone to fires, and areas with slopes between 15 to 25 showed high fire susceptibility across all models. Then the next solution is burn severity mapping, means post-fire assessment after the burn. This is the process that utilizes satellite imagery to classify burnt areas into different severity classes. For this study, we used Sentinel-2 images. Pre-fire images were taken from this date range, post-fire from this, and the planet imaging
I guess Miss Priyanka got disconnected.
Dr. Priyanka, are you still there?
No, I guess she got disconnected. I'll inform her. I have informed her though. I guess she has not joined yet.
Okay, let's wait for a minute. Let's see if
Yes. Arey, yeah. I guess should we move ahead?
I think we can move ahead and we'll ask her to resume from the session.
Yes, yes. She has
So,
asked to move ahead, and then we should move ahead
okay.
with the last session.
So the next session we have is harnessing GIS for humanitarian action, mapping, coordination, and preparedness. So for this session, we have two speakers. First, we have Ms. Anuva Chaudhary, who is a PhD scholar at Birla Institute of Technology. Ms. Anuva Chaudhary is a self-reliant, focused, and collaborative professional with strong organizational and analytical skills. As a PhD scholar, she is highly motivated and adept at fast learning, aiming to contribute effectively to research and development. She aspires to be a part of a progressive organization that offers opportunities in a dynamic environment where her skills and expertise can be utilized to drive meaningful impact. Over to Ms. Chaudhary.
Ms. Anubha?
Yeah, thank you for such a good introduction. I'm sharing my slide. Can you please give me slide sharing access? So is my slide visible?
Yes, it is visible. You can
Yeah.
continue.
Thank you for inviting me as the speaker. I would like to, I'm Anubha from the Department of Remote Sensing and Geoinformatics from Birla Institute of Technology, Meshra. I'm going to speak on how GIS and remote sensing help in multi-hazard monitoring and early warning systems, and how it can help in, as Arkaprabha said, how it helps in the humanitarian grounds. So to start with, we first can see what is the disaster scenarios of the country. And over the past decade, we can see a very high rising trend of disasters such as floods, drought, heat waves that occur and impact populations. So as floods, drought, cyclones, heat waves are basically climatological hazards. It has a wide number of peoples affected due to it every year, and we can see it has a sharp rise since 1960s, and up till 2022 it has achieved a peak. Here are some of the climatological hazards or the type of natural hazards that India faces recurrently. Coming to what is the role of remote sensing and GIS in natural disaster monitoring. GIS, remote sensing and the Earth observation data is widely used in all the phases of disaster monitoring management, from pre-disaster assessment to disasters and post-disasters. During the pre-disaster assessment, hazard zonations map are done to identify which are the risks or the vulnerable zones for a particular disaster. During disaster, how much the disaster has caused impact on it. Similarly, for the post-disaster, it's the recovery and the monitoring, planning for evacuation and resilience. So here is another how the user framework is done for the prevention, preparedness and response using the Earth observation data. I'll come to some of the case studies that used Earth observation data for various types of disaster monitoring. For example, if we come to the example of flood, various types of data such as GPM, Sentinel-1, Sentinel-2, SRTM, etc., can be widely used for monitoring it. This is a paper from the Lower Godavari Basin, which has tried to address the how rainfall has led to flooding in the Lower Godavari Basin, and how it has impacted the overall crops or the agricultural land due to intensive flooding. Similarly, for cyclones, there can be IB track data, INSAT data, which can analyze the cyclone tracks. Then the cyclonic rainfall can induce flooding, leading to a cascading effect of disasters and its impact. Study on climate extremes after the recently occurred cyclone last year, how it has impacted along its track from starting from the Sundarban regions till the northeast in the Silchar plains. So we can use the Earth observation data for addressing the different phases of disasters. Here are some examples from there. We can see how the cyclone track is moving from the Earth observation data, and along the track how the rainfall patterns is also shifting. Similarly, for drought assessment, that is agricultural drought, how with indicators such as VCI, SPI, RAI, how agricultural drought can affect states or overall country. We can also identify how two juxtaposition climatic phenomena, that is floods and drought, occur simultaneously over a region. So for this, we can use various type of data such as models. We have Sentinel-2 for getting the agricultural area, Sentinel-1 for detecting floods. For rainfall, we have CHIRPS data sets. We have the IMD gridded data. So here, a case study on Orissa has been prepared to assess the agricultural drought that widely affected the whole country during 2015. There are various portals, government portals that are available and which provides near real-time monitoring. For example, for drought, we have agriculture decision support system, that is Krishi DSS, which is a dashboard implemented based on the manual for drought management 2020, and with all its indicators, they have developed the dashboard so that we can just change the date and understand what is the scenarios of the drought. Similarly, for floods, we have the flood forecast by CWC. We have cyclone monitoring systems of Satark. So these systems, along with Earth, can have input from the Earth observation data, so that they can be more robust and improve the early warning systems. So the main essence of the today's session, that is how early warning systems are important and how GIS can help in improving the system. So as we know that early warning system is a set of measures that help to detect and forecast a hazard before to take timely actions to reduce the risk of life and properties as well as livelihoods. So for this, as per the UN report, they have provided some of the statistics which says that around 30% of the disaster can be reduced if the early warning issue can be issued in a shorter span of time. With additionally, this could help in reducing the losses incurred by these disasters. People can be saved, people can be evacuated. For example, during the recent cyclone, this early warning system in Orissa had to reduce the mortality because people could be evacuated to a safer location. So, what is the main components of early warning system? It's based on the disaster knowledge that we have, which could come from indigenous knowledge or the historical evidences, how we can detect, or monitor, or forecast the hazard, how efficient dissemination processes, how fast the dissemination processes, how much is the preparedness of its community, how it is prepared to face any disaster, or how have their coping
Anuva, sorry
capacity.
to interrupt. I think you're running against the time. So kindly wind it up as soon as possible.
Thank you. So we have the evolution, how the early warning systems have evolved over the years. So I'm not going into details. For example, these are the what are the existing early warning systems that is there for. There are flood early warning systems, cyclone early warning systems, and how the dissemination process is there. So it's a base for the indoors. It is the siren signals, speakers through which people get to know about the hazard information. The how through indoor they have the cell broadcast, television, radios. Similarly, we get SMS notification from IMD if there is any thunderstorm or rainfall. Then broadcast, FM radios, mobile phones, or so for this, we can have some of the future direction how we could improve our early warning system. That is, we can have web platforms or dashboards that can provide near real-time visualization to assess or forecast any disaster scenarios using cloud platforms like Google Earth Engine. Then application of AI, ML, DL models can also help in hazard research such as flood inundation mapping, drought forecasting, landslide susceptibility, cyclones. For the early warning system could be strengthened using community-centric early warning system, which is a combination from the information received using Earth observation data and as well as through participatory approaches that through citizen science for timely dissemination, advances in research on IoT sensors to improve EWS or other system that can help in the rapid monitoring and management of disasters. These data can be used in used for data fusions to make more accurate and timely responses. Thank you.
Thank you, Anuma.
Yeah.
Our final speaker for today is Ms. Himangi Pant. Ms. Himangi Pant is currently serving as Engagement and Partnership Support Officer at SEEDS. With a strong academic background, she holds a master's in geology from Kumaon University, Nainital, and a diploma in geoinformatics from IGNOU. Skilled in geology, she brings expertise in the geological and tectonic aspect of the Himalayas and Rajasthan, and is also a GIS enthusiast. Hailing from the Kumaon Himalayas, Himangi has worked with reputed organizations such as India Meteorology Department, SHEG, and Six Red Marbles. And for the past year, she has been contributing to seeds in diverse roles ranging from technical writing to partnership development. Over to you, Ms. Pant.
Thank you. Thank you so much for a wonderful introduction. So, good afternoon, everybody. So, I'm Himangi Pant, and I'm currently working with SEEDS as an engagement and partnership support officer. Over the past 3 to 4 years, my work has focused on various alleys of earth sciences. And I have worked with organizations such as IMD, like it was introduced earlier. So with this, I proceed with my presentation. So please give me a moment. So is my screen visible?
Not yet, ma'am.
Okay. I hope it is visible now.
Yes, we can see it.
Yes. Okay. So my topic for today is future preparedness with GIS, scenario planning, documentation, and NGO capacity building. So when we talk about scenario planning, so what major thing that comes in our mind is what if? So what if a disaster happens? Then what are we supposed to do? Are we even prepared? Or, are we prepared with any kind of evacuation plan or a backup plan? Or do we have any routes, evacuation routes or something like that? So here in the image that I have shared here, so this image has been taken from ISRO, and it is from Dharali, Uttarkashi, recently, which was affected by a very disastrous flash flood. So basically, if we can see, this is an image of 2024 and this is of 2025 after the flash flood. So here we can see that there are many ways where the evacuation processes can be done. So it is very important to go through such scenario planning, because it is very important to, in future to take a necessary action so that we can reach out to such places where a helping hand is required. So coming on to the next thing, documentation. So documentation, why is it important when we talk about GIS and on the basis of NGOs aspect? So not just NGOs aspect, but for every organization, what I believe. So using GIS to record and visualize disaster impacts over time. So this is an image that I've shared. It's the river is not from India. So this is a river of Bangladesh, but I'm just sharing it here for a general overview. So when we talk about a river, so it never flows in its same old path. So anytime, anywhere, it can just change its course, or maybe any kind of processes like river capturing or river capturing or stream capturing, it can happen in any of the rivers. So we can never trust a river and its flowage. So it is very important to have a document or have a map which has been documented for, let's say, 10 years old map or 20 years or whatsoever it is. So here we can clearly see that the river is changing its path. So whatever come in its way, so it's going to be washed out anyway. So the similar thing happened in the 2013 Uttarakhand Kedarnath tragedy, where everybody thought that Mandakini River, it's not flowing in that particular old path, so it won't use it anyway in near future. So they started building very strong structures. And like what happened in 2013, whatever came in its way, it just washed out everything. So therefore, there is a very strong need of documentation and documenting everything that had happened in the past for a better future, or let's say for a present, making the present better. So the next thing is capacity building of NGOs. So when we talk about the capacity building of the NGOs, it's not just the capacity building of the NGOs, but the communities associated with them. And here, when we talk about capacity building, then we are talking about, in building certain things, certain aspects which are related to GIS and remote sensing. So why is it important? So it is important to make the NGO self-reliant, maybe to map an area for probable loss, to monitor any area with respect to population or even the existing resources of the community, whether they have basic access to water, sanitation, food, and so on and so forth. So sometimes, in the field that I'm talking about, as an NGO, there's a specific tool which is Kobo tool, and it has GPS enabled in it, so you can geotag the locality, and it gives a very precise location which can be later used for the preparation of a map, a GIS map, or a very specific geo-referenced map, to be specific about that. And there have been many instances in the past where the communities whom we have trained in such things, they sketch the maps by their own, and they also help in marking the exact vulnerable localities, because they know their locality the best and nobody else can know that locality better than them. So it is very important. And again, this is very important because it creates a sense of responsibility among the communities. And it is very important to do that. Unless and until they don't feel that, sense of responsibility, and they don't feel that connect. So many things cannot be accomplished, like good things cannot be accomplished in that particular area. So then, like coming on to the next thing, some of the best practices that have happened. So the best practices by the NGOs with respect to GIS lies in how effectively they use GIS to improve disaster response and strengthen community resilience. So when I say that, so it is like, often there are some open source tools which any organization or any NGO, or even for that, any community can avail, like the QGIS, anybody can avail that because it is an open source tool. And then again, GPS enabled tools, or the kits that we have, again, coming back to the Kobo tool that I was talking about. So this will not only help in marking the vulnerabilities in that locality, but this will also help in preparing beforehand for some kind of situation, an emergency like situation. And maybe like if any school or something or a hospital is constructed over a very vulnerable kind of a zone, so maybe we can opt a process like retrofitting in that area. So therefore, these practices are very, very necessary. So the basic learnings and the major learnings that have happened uh, over the past few years, that I have learned actually. So any map which is isolated, I don't think so personally that it is very useful for anybody. So it is very, very important for all the organizations, whether private organizations or government-based organizations or any communities, NGOs, to come together and work on, let's say, different aspects of some kind of vulnerability. Let's say if one community is working on the public health sector, the other community is working on the vulnerability, and the third is working on the network, the roadways, the railways, and all. So when these different criterias they are put together into a particular map or a layer, layering is done, then we get a very meaningful map which can be used for any kind of situations, and together we can really rule this, and we can really, really help the communities which face such kind of situations every year. So, having said that, yes, that's it. Thank you. So, I request the moderator to take over. Thank you so much.
That was really wonderful. So we will now move on to the open discussion session, and all the participants who are here, if you have any questions to any of the speakers, you kindly put it in the chat box and we'll be taking it. So starting with Professor Sarma. So, sir, I have a basic question. So you said that using thermal IR, we can actually identify the fire affected areas in the coal mines. So I was curious, what is the depth till which we can actually identify using the thermal IRs?
Thank you, Dr. Sarkar. It's very relevant and very important query. Uh, Actually, thermal, we cannot talk about the depth. It basically will give us the differences in temperature. But microwave remote sensing is there. Radar can give us the depth about any objects, any features. If you want to know about the depth of a particular minerals or something like that, the microwave portion of remote sensing can be utilized. Radar can be utilized for the particular purpose. And I think thermal is a very relevant query. And thermal basically tells us about the differences in temperature. If some areas having warmer temperature because of subsurface mining, that surface temperature can be mapped using that particular band. Thank you.
Okay. I have another question, sir. For the soil erosion study that you did for the
Mhm.
Oman project, so what were the parameters that you included in your model, and what was the model that you used to calculate soil erosion?
Okay, actually, it was for micro hydroelectricity power plant, the EIA. For it was done in Tawang Himalayas.
Okay, okay. Sorry,
The
sir.
Tawang Himalayas. So different parameters like slope, geology, soil, then rainfall intensity, then existing landslide hazard zonation mapping done by State Remote Sensing Center. Also, State Remote Sensing Center they previously prepared some soil erosion vulnerability mapping. Then land use, land cover, of course, shifting cultivation areas which are prominent in those areas basically.
And
So
what was
those
the
are the
model
areas
that you
taken.
used over there?
Model here we use very simple model, that is weighted overlay analysis model
Okay,
was
okay, okay, okay,
carried
sir.
out, where
Thank you, sir.
influences and weightages were provided. So that model was utilized for this.
Okay, thank you, sir. I'll move to Mr. Thakur. So it's wonderful that like so many glacial lakes have been identified by NDMA and GSI, and we are monitoring that. But if you see, sir, there are numerous lakes across the Himalayas from JNK to Arunachal, and how exactly do you try to monitor each of these lakes? Because under certain circumstances, the lakes which we are not probably considering them vulnerable might also show an outburst activity, just like the Dharali lake that we saw. It was a very small lake, but then again, it did what it had to do. So, how are we going to use GIS to actually monitor all these lakes across the Himalayas?
question. So please, can you repeat it?
Okay, so sir, actually, my question is across the Himalayas, if you see from J&K to Arunachal, we have a innumerable lakes that are there, the glacial lakes, and it's just a matter of chance or a matter of certain activity which can trigger any of these lakes. So it's a humongous task actually to monitor all of these lakes. So what exactly is the process, and where is exactly is GIS coming in to ease out this process of monitoring?
Yes, yes, that is very valid question you have asked. In my previous slide in second or third, so I have shown the how NRSC has mapped on 28,000 glacier lakes in entire Himalayan region. So in Indian Himalaya, there is almost 7,500 glacier lakes. So various agencies like CWC, GSI, SCC, which is international organization, and some other agencies like IIRS, Notice SEC. These agencies are rigorously monitoring these glacier lakes. There is two ways. One is from remote sensing based study, so we can see the susceptibility assessment of these glacier lakes. Basin wise, we can study these glacier lakes, which glacier lakes are highly vulnerable. Among these, there is a criteria. If you have seen the manual of CWC, there is almost 13 criteria as per the how lake area, potential to exposure to the hydel projects or downstream communities, and slope of the area. These parameters has been taken to identify the vulnerability of the lakes. So in NDMA, we have compiled these weighted overlays, and we have get with the 195 high risk glacier lakes, and we have categorized in category A, B, C, and unclassified lakes. So category A lake, there is almost 150 lakes. There is almost 42 lakes which are in two UTs and in four states like Himachal Pradesh, Uttarakhand, Sikkim, and Arunachal Pradesh. So we are just focusing on these glacial lakes right now, category A risk lakes. What still the GLOF is very dynamic. So glacial lakes are very dynamic. If you can see, the Chorabari Lake happens in 2013. That is very small lakes. Okay. In similar way, similarly, recent day Dharali happened. Dharali I have shown in my slide. So there is two glacial lakes I have identified there. One is at in the top of the ridge, and one is at the upper middle of the area. So how the saturation happens there, and the rain was always the factor to do this induced. So these are some factors which can useful to do some good GIS and remote sensing based study to identify these high risk lakes.
Okay. Another question, sir, you had an early warning system that sends you the photograph of the lake every 24 hours. But if you see an activity like glacial lake outburst flood, it lasts probably for a couple of hours and that's it. Within that, the entire thing is gone. So don't you think 24 hours resolution, temporary resolution is too coarse for a activity like GLOF? And
Yes,
how
yes,
exactly are we going to tackle with that?
yes, exactly. Because in entire Himalayan region, I have been some day before at EC mode Nepal. So we have some international partners there. So very few countries has these EWS done before that. So we have done a POC at proof of concept at these two lakes. So further, we are going to install more EWS, and therefore we need some communications from satellites. Like presently, we are getting communication for Inmarsat, that is European satellite. So in this time, in our NGRNP project, we have a project National Global Risk Mitigation Program that is almost 150 crore projects. So in high risk glacial lakes, we are going to install these EWS. The communication that may be near real time.
Okay. Thank you, sir. I'll move to Ms. Anuva. So, just out of curiosity, I'm asking, you showed a map with the drought severity, and we could see that there is flood and there is extreme drought in a very regional city. So, can you please identify the cause for such a thing? Like, because you're having a flood and drought almost adjacent to each other, and what is exactly the causality between the distribution of drought severity in a particular region? Miss Anuva, are you there? Miss Anuva?
I'm writing to her. So what we can do, we can move forward to the next speaker and then we invite.
Okay.
Okay, some problem with internet.
Okay, so I'll move to Miss Pan. So, ma'am, it was a really interesting way how you showed that way forward of using GIS. But a couple of questions I have regarding this. Number one is, when you speak to the community, and when you say GIS, it's always like a big rocket science, and people are kind of afraid to go into that part of technology or methods. So how do you plan to tackle such problems where how you have to mainstream GIS into the community level?
Okay, thank you for the question. So, okay, not I agree to that point. Not all the communities are so much sound of technologies and such heavy networks and such heavy platforms. For that, what we can do is we use, as I mentioned, Kobo tool we use. Right. So Kobo tool, it gives you the exact GPS locations. They give you geotagged images. You can click images. So that is how the communities can collaborate and tell us about the exact location. So that is one way of them to contribute. So post that, those particular geotags or those particular localities can be used by somebody who is sound in that knowledge of GIS and can, let's say, frame it in a form of a map and produce it very digitally and very efficiently. So that is a way. I hope I answered your question.
Yeah, yeah, definitely.
Thank
The
you.
next thing that I would want to know, because I've been like working with the communities for to develop a sort of precipitation data set with a community centered approach.
Mhm.
And one of the major problems that I was facing was the data authenticity, because I cannot really assure that the data that is being entered by the communities or the individuals I've entrusted with this thing is actually accurate or not, because at times they would miss and they would put in some other data, or the instrument is probably malfunctioning and they're still putting on the data. So that is one inherent problem I have faced while working with the community. So do you have any solution for that? Like,
Okay. So this particular thing or this particular question was asked in a morning meeting that I was a part of. So I'm glad this came again. So mostly this such situations barely arise, but if they do arise, then we have our team always there who can monitor such situations and go on ground and check any kind of malfunctioning is happening or something like that. And mostly in most of the cases we get the correct information from the communities. Like even if we had any kind of what do you call it, a group of experts, if we create a community like that and then we happen to visit that particular location, so more or less the information matches. So yeah.
okay, so that is that continuous validation required over time to time?
Sometimes, like if it is reported, and mostly, as I said, that not such mistakes or such things are very common. But if these things are common, then our team or any technical expert of ours, they visit the ground.
Okay, thank you.
Yes, thank you.
I'll move to Anuva again. So I'll repeat my question. Uh, Number one, that you showed that there is drought severity in drought severity map that you showed. There was flood and intense drought that was happening within a very regional scale. So can you please throw some light on the causality of such phenomena where you're getting drought and flood similar to each like close to each other?
Yeah, thank you for the question. So, in 2015, when I was doing the analysis, I found some flooding signatures in a district of Jagat Singapore, which was a very dry district 1 month before. And due to the change in precipitation patterns, the localized precipitation, we can see the diverse phenomena, that is flood and drought, occurring together. And the drought flood was also very severe, that it led to a death of around 11 to 14 people, as reported by IMD. And
So is it entirely due to the precipitation difference that we are getting drought and flood together?
mm, it is also due to the El Nino effects we have. That year was a year where there was a El Nino effect going on, with very localized precipitations, um, extreme precipitation rather. And
El Nino, as I understand, it's a global effect. So it's like, would it affect the it to a regional scale, that within few tens of kilometers or few tens of kilometers, that precipitation patterns would change and would cause drought and flood together at the same time?
so, yeah, because as we know that climate is very unpredictable, it can change. Rather, weather is very unpredictable. The global as well as the local phenomena that interconnects with each other and give rise to such phenomena. Additionally, the physiographic conditions also have an influence on these type of parameter impacts.
Okay, thank you. So that was a very wonderful session. There were some interesting queries for Dr. Shukla, but unfortunately, can get to her. So,
I'm here. I can
She's
answer.
here.
okay. So, Dr. Shukla, I have a couple of like few questions. Number one is 2005, 2003, you showed that there is immense forest fire in the Mizoram region. So is there any particular reason why during that time we saw such peaks over there?
It could be I guess it could be due to the climate change, one of the reason, or climate anomalies like El Nino. The effect of that could also happen, and besides that, shifting cultivation is also one of the reason in this region. So this could be the probable reasons.
Okay. And another thing is the hot and cold spots that you were showing, and over time that they were shifting, the cold spot was turning into a hot spot and things like that. So what exactly is the reason behind such shifts that you were getting?
Uh, Shifting agriculture,
Okay.
shifting agriculture is one of the reason, and also the climate anomalies. It's
So if
a
there is a climate anomaly, is it possible that a hot spot can also become a cold spot in the future?
Means I think the climate change is one of the major reason, and it is a cycle. Like if region is being a hotspot, then in the near future it could be the cold, and then again the hotspot.
Okay,
Like
so
maybe the
it's not a unidirectional shift that we see, that cold to hot.
no, it's not.
Okay, okay,
It is unpredictable.
okay.
I
Thank
guess there is one question from Ms. Himangi Pan to Dr. Priyanka Shukla, that how westerlies are adding to forest fires.
Westerlies.
Are adding to forest fire. Forest.
Basically winds cause the means winds ignite the forest fire events. Like let's suppose a particular area is burnt and a strong wind comes, then there is a chance of spreading of fire in the different parts. So it increases the probability of fire spread in the other regions as well.
So is this westerly particularly responsible for such thing, or is it just that?
No, there are many other reasons, like slope aspect, curvature, the vegetation index, like normalized difference vegetation index, the moisture in that particular region, or the condition of the vegetation over there, the solar insolation, amount of solar insolation in that particular region, uh, or like and other reasons like the rainfall event.
Okay,
So these are the like broadly we can say these are the reasons.
okay. Thank you. I hand over the platform to Sanchita.
Okay, sorry. So good evening, everyone. On the behalf of Spare India Academy, Sanchita Biswas, would like to extend my sincere gratitude to all of us joining us today for the such interesting webinar on harnessing GIS for multi-hazard disaster monitoring and advancing early warning system through spatial intelligence. Your active participation has made this session truly insightful as India continues to grapple with multiple hazards. The role of GIS and spatial intelligence in disaster monitoring and response cannot be overlooked. Your commitment to learning and sharing experiences that technology driven solutions are localized, inclusive, and impactful. A special thanks to our distinguished speakers, Dr. Kiranmay Sarma sir, Mr. Ashok Thakur sir, Dr. Priyanka Shukla ma'am, Ms. Anubha Chaudhary, and Ms. Bhangi Pant for their thought-provoking presentations. Your insightful on risk assessment, early warning, forest fire resilience, and humanitarian applications of GIS have provoked the participants with both technical knowledge and practical strategies. We are equally grateful to our moderator, Dr. Arka Sarkar, for his excellent facilitation, which ensured smooth flow and engaging discussions. Finally, to our participants representing government agencies, NGOs, academia, and community stakeholders, thank you for your time and contributions. Your engagement strengthened the collaborative effort to advance GIS-enabled disaster preparedness and resilience in India. We look forward for a continued participation in future Spare India Academy sessions as we work together to build safer and more resilient communities. Stay safe, stay connected, and thank you once again for being with us today. Thank you.